So here's our basic parabola. The basic parabola, the equation of it is just y equals x squared. And so in the basic parabola, the vertex is at 0, 0, as we have here. When compared to the standard form of the parabola, the basic parabola has an a value of 1. And when the a value is 1, we notice a certain pattern. Starting at 0, 0, it goes over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7, and it keeps doing that pattern of going the next odd number. Anytime your a value changes, that scale changes by just multiplying it by whatever your a value is. So if I were to graph y equals 2x squared, I would know that my vertex is still at 0, 0, but now I'm going to go over 1, up 2, over 1, then up 6. So I would have the point 1, 2 and 2, 8. Same thing on the other side, and you could draw your curve through those points, put arrowheads on the end to show how it goes. So in this one, over 1, up 2, over 1, up 6 occurs. So the normal odd pattern of 1, 3, 5 gets multiplied by 2, and it will go 2, 6, 10, 14, and so on. If you have a fraction, pick a fraction. 1 over 2. If you have 1/2 x squared, you would still have your vertex at 0, 0, but now you would go over 1, up 1/2, and then over 1, up 3/2. So you would have the point 1, 1/2, and 2, 2. Same thing on the other side. And this one makes it wider. If we draw the pattern here, over 1, up 1/2, over 1, up 3/2. Can you see that if you go from 1/2 and add 3/2, you would get to 2? Okay? Now, sometimes with the fractions, it's hard to graph it exactly right in the exact spot that you would like it to. So sometimes you can just think, what would be a number that I could plug in for x that would be easy to divide by 2? Like if I plug in 2, 2 squared is 4. 4 divided by 2 is 2. So when x is 2, y is 2. So sometimes you can go back to just your regular table of values to find points that will be on your graph as well. So let's look at example 2. Example 2 wants us to sketch this graph and identify the direction of the opening. Is it going to open up or is it going to open down? How do we know? Where's the vertex? How do we know? What's the axis of symmetry? How do we know? What are the intercepts, x-intercepts and y-intercepts? And the domain and range. Usually for all of these questions, it's actually easier to do part B first. If we start with our sketch, on our equation, the first thing I always look for is the vertex. This is in standard form or vertex form. Whenever you have the equation in this form, the value of P and Q are the values of the vertex. So in this case, the fact that I have minus 3 and plus 1 means that my vertex will be at 3, 1. And from the math lab, we learned that that minus 3 moved things 3 to the right, and the plus 1 moved it up 1. So our vertex is going to be at 3, 1. And as far as graphing, what's that? No, positive 3, 1. It is x minus 3, but whatever's inside from the math lab was switched. Because what would make this 0 in here? A positive 3. So we have our vertex at 3, 1. One's inside the brackets is always in the opposite direction, and what was outside was always what you saw. Good questions, though. So we have our if it was x plus 3, then we would go 3 to the left. So whatever's inside the brackets is kind of opposite of what you would see. And so we have the point 3, 1. Because it's a positive 1/4, you know that it's opening up. And so we're going to go from our vertex, we're going to go over 1, up 1/4. Over 1, up 1/4. Then over 1, up 3/4. Now I'm dealing with fractions, so that gets a little bit tricky. Maybe I would like to plug in a value that would be easy to calculate. For example, can you see that if I plug in 5, 5 minus 3 is 2, 2 squared is 4, times by 1/4 would be 1, plus 1 would be 2. It's a lot of mental math all at once. I plugged in 4 for x. I plugged in 5, sorry, I labeled it bad. I plugged in 5 for x. Calculated what y would be, and y would be 2. The same thing could happen if you plugged in 1. If you plug in 1 for x, you'd get negative 2 inside the brackets. Negative 2 squared would be positive 4. Divide by 4 would be 1. Plus 1 would be 2. And so our graph, our parabola is quite wide and looks like this. The equation of the axis of symmetry. So on our graph, we can take out a red pen and with a dotted line, draw a vertical line through the vertex, and that will be our axis of symmetry because the parabola is the same on either side. It's symmetrical. The equation for the axis of symmetry is always x equals, because that's the equation of any vertical line, and it will always be x equals whatever the x coordinate of your vertex is. The intercepts, can you see from our graph that there are no x-intercepts? If we want to find a y-intercept, algebraically, how do you find a y-intercept? How would I find this point right here? It'll be 0, something. And if it's 0, something, I can plug in 0 for x. If I plug in 0 for x, I'm going to get, all right, let's check your mental math. Did I do that right? 13 over 4? Because 0 minus 3 would be negative 3. Negative 3 squared would be 9. 9 times 1/4 would be 9 over 4. Plus 1. Have to get a common denominator. 9 over 4 plus 4 over 4. 13 over 4. So my y-intercept is 13 over 4. finally, domain and range. Domain of a parabola is always everything. Your range of your parabola is based on your vertex. Can you see that the smallest value is y equals 1? And then it goes up from there. So our range would be y is bigger than or equal to 1. Okay, practice some graphing. Questions 6 and 8.